with this. So to just introduce about myself, so I'm just not gonna read much stuff. You can just have a quick look. So I'm a master's student and security researcher at Carnegie Mellon. My majors is information security. The main reason for keeping Carnegie Mellon in quotes, you know that the name Carnegie Mellon adds so much to you. And our university is actually Ashwin for information security. So I wrote a book and have done quite some other stuff in information security. So I've been doing AppSec for quite like past 4 5 years. AppSec network, not much network system and other stuff, but from past 6 to 7 months is when I found this container security field very interesting, and I'm actually doing a lot of active research on this. Uh, so coming to my experience with Docker containers, so I've been doing, as I said, active research with renowned professors from past 20 to 25 days. I'm not in much touch. I'm doing other stuff, but I'm actually going to continue my research again from the next week. So I also worked as a cloud security research intern at Adobe, where we are researching at the container security and also going to provide recommendations to the container security container platform that Adobe is actually building. So apart from that, one more thing is CIS Docker 1.12 benchmark. I co-authored it with a few other people from NCC, VMware, and others. So you'll find most of the points, or I would say few points from that in this presentation. It's not actually, the CS benchmark is not actually a replication of this presentation. It's a totally different thing, but you'll find few points of that over here. So I also might be working with SCR CERT as a research intern on container security from next month or so. And then that's it about my introduction. So before we actually jump into the topic, I first want to ask few pre-questions. How many of you actually use? No. How many of you know what containers are? Okay, pretty good. How many of you guys use containers for personal use and for enterprise? Awesome. Yeah. And so in enterprise, do you guys use it for development or else production? Anyone? Both? Okay. Who use it only for development? Okay. And who are the guys are very much interested in containers but are still waiting to use it in development or production just because of security concerns? Anyone? Okay, I was actually speaking to one guy while I was moving around. So he actually told me that I asked him whether do they use Docker containers or something. The first answer he gave me was no, Docker is not secure. We don't use it. So I was kind of a little surprised with that. Yeah, there are security issues, but yes, we can actually do mitigate most of them and make our Docker ecosystem secure. That's what we'll be talking about stuff today. And so this is actually our agenda for today. So I'll be, and one more thing, if you have any question in between, you can just raise your hand and ask me. If you can stop that question till the end where I have like 5 to 10 minutes of Q&A, you can stop it. Or else if you think that you cannot understand the rest part of what I'm explaining, if you don't get a clarity on that, feel free to raise your hand. Okay, so this is our actual agenda for today. So I'll just, as many of you have raised hands that you know containers and all that stuff, but I found few people who didn't actually raise hands. So I'll just take 1 minute to quickly do a dive on what containers are and introduction stuff. And then we'll be looking at the security part, each component of the containers, how actually it works and all that stuff. And also apart from that, we'll be seeing like a holistic view of entire container pipeline. What are the risk areas? What are the things that you should actually take care of and all that stuff? And the few tips, future and all the miscellaneous things. So I actually have so much stuff to explain. So I'll actually be moving a little fast, but if you guys feel that I'm actually going out of your head or something, just feel free to raise your hand so that I'll stop and explain. So just as I said, giving a brief overview of what containers or something. So this is the difference between virtual machines and containers. So here if you see virtual machines or like you have individual OS for each of them. But containers, you don't have individual OS. So it's like application centric. Containers are application centric. They share the kernel. I actually cannot see from here. I'm not sure if I'm pointing to the right one, and over here it's like very small. So if I'm pointing to a wrong one, please just try to understand. I think this is Docker engine, right? Yeah, so no, that's not Docker engine. That's the OS where the kernel, they share the common kernel, and on top of that, containers build on top of that. So that's the main difference between containers and virtual machines. And coming to the next thing, so the major use cases for containers are like they're really lightweight. I mean, so if you the stats released by IBM Watson Research Center and a few other people where they said like you can run 4x or 5x times or even more times of containers than virtual machines on a machine having a particular amount of RAM and other configs. So they're really lightweight. So you understand that the reason being that there is a common kernel which every container shares, but in the virtual machine you have to package every particular thing. So that's the whole thing. So they're really lightweight, and containers are actually meant for application centric, and it's also like no more. So you guys know pretty much about it, so I'm not going to spend too much about it. So it's all about microservices again. So one more, the basic building blocks for containers are namespaces and C groups. Namespaces are actually a kind of view isolation. So say something like a process namespace, PID namespace is nothing but a container in a particular thing, particular process namespace will not be able to see process namespace, processes of other container. So it's kind of an isolation view for entire process, UTS, file, network, and all that stuff. And C groups are the ones which do limitation. So say limiting, accounting, resourcing kind of stuff. So say something like how much CPU each container is using, how much memory each container is using. So those are the two basic building blocks for containers. And actually, so if we actually have to say like, or containers brand new buzz, no, they have been from quite some long time, like a decade or so. It actually started from CH root, where it's quite very long back actually. And after that, there's been like jails, Sway servers, and all that stuff, and LXC, and LXC after that, Docker, and after Docker, Rocket. So they have been quite from long time, but the only reason why people are using containers these days pretty much is that because of the Docker. Docker made the ecosystem very easy, such a way that everyone can use it in a very simplified way. So that's the reason containers have become very buzz these days. Wherever you go, Docker containers, Docker containers. And other container technologies didn't gain much recognition so far, but Docker is one of the ones that actually gained so much, and that's the reason I'm actually concentrating on Docker today. So coming to the environment actually, so this is the particular container environment. So this is specific to Docker, but the same core concepts generally apply to other container ecosystems too. So if you see how container pipeline actually exists, or how the workflow starts from container, right from the starting till the beginning and all that. So you can see here, client, I'm sorry. So you can see here, client is the one where you actually issue the commands, Docker pull, push, or whatever it is. And Docker host is the one where you have the entire daemon, which takes care of managing the containers and images and all that stuff. And then, so people generally for personal use, they keep Docker daemon and the Docker client on the same host, but at enterprise level, they do segregate it on different hosts. And this is a Docker hub where people get images, and this is the same hub kind of thing, but a private thing. So daemon keeps contact with Docker hub to get the images, and images are actually spent to containers. So this is how the workflow starts. Client issues a command, and then it goes to daemon, and then daemon, if needed, goes and gets the images from Docker hub or else a private registry, and then keeps everything managing here. So this is the environment that a container pipeline will actually be having. So now, basing on what you see the container pipeline now, what do you think are the risk areas here? Anyone? So the quicker you answer, the more I can cover. So
it's the shared OS, and the system calls for the shared OS.
Perfect. That's
The namespace really isn't segregated as much as they'd like to tell you it is.
Awesome. Yeah, that's one point. And others? Oh, good. Yeah, that's one thing. And yeah, and what are the risk areas do you guys see?
malware. I mean, infected, you can pull just, anything, a circuit, you can pull infected, or backdoor, containers from images.
Yeah, good. So that all comes under images security section. Yet, yeah. So apart from images and any registries and all that stuff, any other things that you can see or say out? Oh, good. Yeah. And yeah, correct. That comes the concept of shared kernel where you can actually put that point. But yeah, that's a good valid point. Okay, so let me just go ahead and say how I actually see the risk areas. What kind of risk areas do you find and how do you actually need to concentrate them? So images is one risk areas as you guys said, and other thing is the container runtime. What things might happen when when the containers are in action. Another thing is the daemon itself, which is running the containers. And the other one is the host system where you're running your containers. And the other one is kernel or containers isolation, as she rightly pointed that. The point is about the shared kernel concept. And the other one comes about the communication between the daemon and the client and the daemon and the registries. So these are the major risk areas that you can figure out on a high level. The sockets and all that come either in one of these categories. So mostly these are the ones, high level risk areas that you'll be seeing at Docker. So now the same image that I have shown earlier, I just made it a little more elaborative so that you can figure out a little more details about it. So these are the ones that we actually need to concentrate. These are the pain points. So these are the risk areas that we need to take care in our container ecosystem. So the client itself, so now if you see here, the client itself, this client should have some hardening controls. I'll be talking more about that when we come exactly into that host security segment. And also the daemon itself, the daemon which is managing the containers, images and all that stuff. And the communication between the daemon and the client, and the daemon and the daemon and the client, and the daemon and the registries itself, and the security of the images itself, the security of the containers itself, and the security of the registries overall. So these are the pain points. So these are the areas that we actually need to concentrate on. So now this is much about introduction to what container ecosystem is and what are the pain points and all that stuff. So we'll actually be jumping now to the security part. Before I actually go into that, so there are few things that I would like to say. The abstract that you saw on the website, you'll be seeing the entire part that I mentioned over there, each and everything in this presentation, but it's not going to be a single strike by strike way. So the same way the abstract is written, you cannot see the slides in the same order. So it's all scrambled up in between based on the ecosystem that I talked about. So I kept all images at one part, runtime at one part. So at the end of the presentation, you'll be seeing all the topics over there, but they are like little scrambled ahead. So this is the kind of thing that I like to share. Like this is the past. What actually people used to say is like containers do not contain, or else they say like they're not secure and all this kind of stuff. So there is one stats, I think it's released by Forrester research team. So they said some X%, I think it's 53% of the decision makers are worried about the security of the containers. As the same person whom I spoke earlier, he said containers are not Docker is not secure, so we don't use that. So that's actually kind of past. And so containers are actually production ready now. So if you see Docker has done a lot of development in security stuff. I do not say it's 100% secure, and that's the whole reason I'm giving this talk today. So they have done a lot of stuff and they're actually production ready now. So Google itself spends so many containers, I think 2 billion containers per week or so. So, and coming to the future, containers are actually the future. People are actually migrating to containers. They are like, okay, we'll move to the containers. So it's all about microservices and I get easy, lightweight deployments and all that stuff. Okay, so this is the one goal of this presentation. So Docker says on their official website that they are secure by default. And NCC group report on containers says that Docker default security settings are quite good. By the end of this presentation, I'm still saying it now, by the end of this presentation, even you guys will agree that Docker is not secure by default. You have to do a lot of security settings so that you can make it secure. So this is one of the main goal that we'll be seeing. And one of my main approach for explanation, as I said, I divided each into different components: images, runtime, host, daemon, and all that stuff. So we'll be dealing about how each thing can be broken and how each thing can be secure. So my approach for this explanation is like, I initially thought of explaining only a single particular thing and go in depth into that. But rather than that, I thought that I'll just give a broad idea about each segment and refer people to a particular resource where they can go and find more details about it. So I'm actually doing a particular pain point. What would you have done such a way that it would have been broken, and how you can actually fix that. That is what we'll be seeing today. So over the slides, I have the entire details about what are the pain points and what are the things that you need to take care. And I'll be explaining like how would you actually would have broken that and how you can actually secure that. So this is the kind of approach that I'll be dealing today. And so the main pain point that we first talked about is the images. So let's talk about images. So Docker images, before going into the security segment of the Docker images, I am actually going to give a brief idea about what images are, how they actually work and all that stuff. So Docker images work on a layer basis. So they have individual layers. They use a union file system model. So where everything works on a layer basis. And the top one that you see over here is the thin writable layer. So how it actually works is like, this is a container, this is a container, this is a container, they have a shared kernel. All of them use the same shared kernel. And now if I do some changes, I have a thin writable layer for my container, which it actually works on copy on write model. So the changes that I do for that particular container will be only saved on that top layer for that container. So each container have their own layers with all the changes that they have done, but the shared kernel thing still remains the same. That is how containers images layer thing works. So this is the life cycle. You just write the Docker file and then build the image, and then you spin up to a container. So you'll find something called manifest. Manifest file is nothing but where you have the individual details of the entire images. So individual details of the entire layers of a particular image. Now coming to the question, where do you get images from? Any quick answer, please? Where do you get Docker images from? Registry? Private or public, or what's that? I mean, so when I ask the question who used Docker, many people raise their hands. But now, yeah, please go ahead. Yeah, Hub and any other source? That's good, yeah. So people generally use Hub, and few people are also using their private registries. And Docker has, not very recently, but yeah, not so old also. They released something called Docker Private Store, where they have enterprise level images and kind of more secure. I didn't explore more on that, but yeah, it's on my task list to explore more on that. So can I use these images directly? That is the question that we should be talking. Yes, people say maybe yes, we can use it, but no. I'll say the reason why you should not actually be using that and alternate sources where you can get images from and all that stuff. So the main reason why you cannot or why you should not use Docker Hub images, at least, so Docker Hub is like a place where you have images, general images, official images. General images or it's same like App Store, where you have everyone publishing, or Android, everyone publishing their apps and all that stuff. So Docker has official images which Docker itself publishes, and the general images which either you, me, or anyone else can publish into that. So general images are the ones which are published by other people, and Docker has something called Nautilus, which is also called as Docker security scanning. So they scan these images and try to figure out vulnerabilities, what kind of vulnerabilities are present and all that stuff. They do this scanning at least on the official images, but general images are untouched. So it's not good to use general images at all, at least for enterprise use. And for personal use, maybe if it's not that crucial, yes, but you always, it's not security proof. Like it's not like any vulnerability proof or something. You have a lot of security issues if you use that. And as I said, Docker private store is one which I didn't explore much. I got the beta invite approval just a few days back. I think they started rolling out very recently. And then I can't actually see this. What's that? It's gone with. Okay, as I said, they are not actually scanned with Nautilus. Official images are scanned, but not the general images. Now, the main reason why I am actually saying that we should not be using general images, or for enterprise use at least, is that, so these are the quick results from a report called Banyanop. So they have released a report in which they said 30% of official images are vulnerable and 70% general images are vulnerable. So they have a lot of vulnerabilities, and this is a report in 2015 that was made, and few highly vulnerable packages are like, I think, OpenSSL, Mercurial, and I think Bash, apt. These are the most vulnerable packages that they found in the images. So this is a 2015 report. After that, Docker started releasing Nautilus or Docker security scanning and trying to figure out the vulnerabilities and work with the vendors to fix them. But still there are, as I said, general images are still not touched. It's all the work that's going on with official images only. So Docker images are not actually quite ready. And one more thing, as I said, I have done some analysis on images. So I just downloaded a few images and started analyzing. So the first image that I downloaded is something like Docker UI, and then I started doing it. Within just 1 minute, I found there is XSS vulnerability in that. I'm being frank, the first image I just downloaded it, and within 2 minutes I figured out it's as an XSS vulnerability. And then I started doing the image security analysis with a tool called Twistlog, where I found many vulnerabilities with few packages, even in the official packages itself also. So there is vulnerable Tor version, glibc version, Apache version, and all that. So this is kind of proof that I gave in another presentation, but it's not much of interest. What we actually need to know from this is that Docker images, at least the general images, are not for enterprise use. Even for personal use, maybe if you are security very careful, you should not actually be using them. Even official images, you have to be taking care of few things, which I'll be telling now.
Question.
Sure.
So how much more effort does it take to make it in the enterprise ready?
Yeah, that's coming in the next slides. Yeah, let me know. So this is the thing that we learn now. So one core point that we should not be using Docker Hub images, at least for the enterprise use. Okay. So now I said this is the problem. Then what is the solution? What should I actually be doing for solving this particular problem? Well, yes, you can do few things. You can make your own Docker images in a secure way and host it at your enterprises. This is what we are actually doing it. I'm actually suggesting for few enterprises too. So the two things that you need to concentrate under this segment. Point number one, you need to concentrate is how you should securely, as you know, the Docker file, Docker flow works like this: Docker file, image, and then the container. So the flow works like this. And if you see, you have to start taking care of security at the Docker file itself. While you write the Docker file, there are a lot of security mishaps that you can do, which we'll be seeing now. And after you write the Docker file and you build the images, there are other security constraints that you have to take care, without which you can't maintain the images securely. So those are the two things. Now coming to the first particular thing, like how we can actually write Docker file securely. So this is where I'm talking about a particular point. All the work that I have done and a few other people have done in the security segment, they have actually inputted everything into the CIS Docker benchmark 1.12. It's the latest one. You'll find a lot of very useful information over there. So you can tune it as per your organizational requirements and use it. So one particular point is like use version pinning mechanisms for base images and packages. So the main reason here is version pinning mechanisms is nothing but whenever you're having an image, you say image 1.2, image 1.3, image 1.5, image latest or something like that. The main reason why we are suggesting to use version pinning mechanisms is like Docker has an issue that if I download image latest, say something like there is an image for which the tag is latest. The image latest, I just pulled it and I have it locally on my machine. And when I'm doing a pull again, so the one other guy has updated the image latest and he kept the same tag again, but he updated it. Docker allows that. Few registries like npm and other do not allow it. Docker Hub allows it. So I have image latest. I did download it. Someone, the same guy replaces that again, keeps the same tag as image latest. Now when I do a pull again, because I already have the image latest on my base machine, it won't get the latest version. You'll still have the vulnerable version on your machine. But if you do a version pinning mechanism like 1.3, 1.4, 1.5, 1.6, now whenever the guy updates, he'll be pushing 1.4. Earlier is 1.3. So now, earlier I'll be pulling 1.3, next time I'll be pulling 1.4. So this is one security issue that many people are not aware of. They'll be getting the cached local vulnerable copies. So if you didn't use this, as I said, the break would be like you'll be getting the vulnerable cached local copies. And the fix would be like you can actually use the version pinning mechanisms for solving this problem. And the other thing is like while you're downloading packages in your Docker files, use secure mechanisms like GPG and all that stuff. If you don't use it, you'll be vulnerable to MITM attacks in between where the packages are being downloaded to your machine. So if you use GPG mechanisms, you can verify whether the packages are downloaded properly or not. And few other thing is like, as everyone know, people say that containers by default run as a root. And that's one very big security concern. So if you run containers as a root, you're actually giving so much privilege to them. And if you're not enabling user namespaces, you are actually making a container root as the host root itself. So it's a very big security violation. So if you create a user while you're building Dockerfile itself, what actually happens is that the particular container will run as that particular user only. So there will not be privilege, there will not be violation of least privilege principle. So you can see each point I'm mentioning over there, you can go and get more in details about all of them in the CS Docker benchmark. And the other thing is like, do not update instructions alone. Do not write update instructions alone in the Docker file. So I started explaining this to the CIS team. Everyone started saying that this is not a thing that we should be worried about and all that stuff. But then I finally convinced them. So the problem is that now if I write something in Docker file saying an update instruction line, apt-get update or something, how Dockerfile works is like every particular line will form a particular layer. So now I write apt-get update xyz. So it will form a layer. Now when I write apt-get update again, sometime when I'm using apt-get update again, sometime at the later build, it will get the same cached update layer that is there on the machine. So in the earlier build process, there is a cached layer that is the apt-get update layer that is cached. Next time also I'll be getting the same thing. I'll not be getting the latest updates from the repository, but I'll be getting the cached local copy of the entire update. So you are actually not getting the entire updates and you'll still be using the vulnerable copies. So that's one thing you should be careful about. And set UID, set GID permissions are the ones that you need to remove. You can remove this at the image level itself while you're building the Docker file, so that you'll not be vulnerable to privilege escalation kind of attacks. So you'll find the scripts and all that stuff. How do we remove that and all that in the CIS benchmark? And I'm not talking much about the general rules. It's about increased attack surface. The more you install, the more you have the attack surface. And do not write secrets in the Docker file. This is one very interesting thing. So I think there is one incident in Twitter, I'm not exactly sure about that, where they have kept their environment variables, they have kept their secrets in environment variables in the Docker file. So anyone who gets your image will be able to see the Docker file just by doing a Docker inspect of the particular image, or just by doing a Docker history of a particular image. He will be getting the entire Docker file itself. And if you store your secrets in the Docker file, he'll be able to see the entire secrets. So that's what people do. They pass secrets in environment variables and they write the environment variables in the Docker file. That's actually a very big security thing. So now people might ask me, what do I do then? So maybe good. You have to use some solutions like Keybase, Vault, which allow you to do secure sharing of environment variables. And coming to the next thing is about copy instead of add. So this is one pretty minor thing, but really crucial. What actually copy does is it copies a particular package from your host machine to the build process where you're doing it. And add does download a particular package, unzip it, and then extracts it or something like that, and then pushes it into the image. This way, you have multiple issues, like what if the remote package that you're downloading is vulnerable, and what if the extraction process is vulnerable and all that. You are actually getting an additional security overhead which you need to take care of. But if you use copy, you download it and you do all your tasks manually, and then you push it. But if you use add, you are not getting the chance of doing all that stuff. It downloads and then extracts and then directly goes into the images. So prefer to use copy instead of add. And health check command is like, again, minor thing. You'll get to know much health check details about Docker. And Gosu, this is also a generic thing. I'm actually skipping few generic topics, which are pretty implicitly understandable. So now this is how we actually write Docker file securely. Now comes, okay, I write the Docker file securely and I have the images properly on my machine. What do I need to do for maintaining my images securely? First thing, enable Docker Content Rest. Docker Content Rest is an excellent thing. I worked on it for almost 1 month, understanding the framework and all that. Trust me, it's not easy. It's a little complex framework. It took quite some time for me to understand that. So it is based on a framework called Thandi framework, which Tor used for update systems. So this ensures freshness, integrity, confidentiality guarantees to images. If you don't use this Docker Content Rest, you are vulnerable to a lot of attacks. At least in the enterprise level, many people started using Docker Content Rest. It's really important. So it ensures the 3 crucial properties for images which are not ensured. So say something like, if I don't have Docker Content Rest enabled, and on my registry, an attacker jumps into registry and then he does changes to the layers or the manifest file or something, and then I do a Docker pull next time, my machine will not be able to detect that. The integrity violations, if someone modifies or tampers the image, my machine will not be able to detect that. And if I enable Docker Content Rest, my machine will be able to detect any kind of modifications, and it will know whether the image is coming from the person whom he actually said he is. So this is a very complex framework. You have to work a lot on that, and you have to build something called your own notary setup, your own certificates, your own keys and all that stuff. So you have to go a little more in depth into that. So I have a presentation which I gave at Adobe. I'll see if I can post it, or you guys can reach out to me if you are interested in more details about it. So how do we do a notary setup at an enterprise level and all that stuff? So this is very crucial, important thing. Using this will provide all the guarantees that I mentioned over there. And the other thing is, you should be maintaining these images vulnerability free and do a frequent scanning things, maybe tools like Twistlog, Nautilus, Klog, or Aqua. So these kind of tools allows you to scan images. So one more thing you need to be very careful about scanning mechanism is like few tools, just what do they do is like they scan the image and they figure out, okay, they just write tar -, version, and the output that they get, they match it against the database that they have. It's just a simple source code thing. I can change the source code, recompile it, and make it output a different version number, not vulnerable version number. There are tools who actually do that. So while you're doing any analysis tools for image analysis and all that, you have to specifically ask your vendors for this thing. How do you scan images for vulnerabilities? Do you do a binary level search, which Nautilus does, or do you do a hash level based comparison, which tools like I think Twistlog or Klog does? So you have to be very specific about this, or else if you just do a version string comparison thing, anyone can definitely change that and do that stuff. So up to date and Docker benchmark are general points. So before I jump into container runtime, I would actually pause on for a minute if you guys have any questions, or else we can go ahead and start runtime. Yes.
So all this mechanism like trust and those things, I understand that you're talking, but in the enterprise environment, if we have access control pretty tightly managed, is it required?
So you say even we have access control strictly, do we need content rest or no?
Right.
No, I mean, what access control do you mean in this scenario. In case of containers, what access control do you mean?
Well, the container image, when I look in the registry, if I minimize the access
To the registry
to
itself.
the registry itself, and then
Okay.
the processes of control, would that be,
Yeah, yeah. See, there are always workarounds for this, but I would say, I would see this scenario in this way. So you have a vulnerable component here, and what you're saying is that I'll keep this vulnerable, and then I'll secure my entire perimeter. This is not what actually security principle works. So security principle says like you don't keep anything vulnerable itself. So even though you keep something hard security controls or something around the registry so that people cannot access it or do any changes or something, what if one day people come, someone managed to get into the registry? It's just a kind of defense in depth measure. So tampering images is one thing that maybe people can prevent it. How about the confidentiality? How do you achieve the confidentiality in an access control environment? How do you achieve the freshness guarantees in an access control environment?
well, there is a practical way and there's a theoretical way. So in there's certain level of access control restriction, authentication, authorization, that you can do to have access to the images.
Yeah.
I'm not saying that's theoretically errorful, but it is enough from a practical perspective.
Yeah, I got you, but I would say, I mean, my personal suggestion, I, being a security guy, would always believe this. I don't want to keep anything vulnerable and do an additional way, such a way that I don't need to work around that, but I'll do a workaround around that. I would feel like I don't want to keep anything vulnerable. I would just patch that rather than doing an additional security controls. So in this scenario, Docker Content Rest, it would take quite some time for you to set up all this stuff. But as you said, if you're doing a very restricted enterprise level, say something like only between me and a particular machine, no one else has access and all that stuff, then yeah, it makes sense. Maybe you can do an additional control. But again, the point is you're still leaving that vulnerable.
So I probably didn't understand the word image itself. My understanding is you protect the image, the content trust.
Correct.
So you want to verify the integrity of the image, but the image itself is considered a good image, right? So there's no vulnerability. I mean, if there is vulnerability, we produce a new version. So the question is about how to guard this image so we don't use the wrong version, right?
Oh, see, the point when I mean vulnerability is not about it is having vulnerability. The vulnerability is tampering of images. When I mean vulnerability, it means tampering of images. Say I have 100 images in my registry. What if someone tampers it? And when I do a Docker pull, I'll actually be getting the tampered image itself. But if I do Docker Content Rest, it says me that you are getting a tampered image. It's not the original image that you actually have to get. Sure.
So in the enterprise environment, basically, the reason I raise this issue is it's important is one fewer things it goes a long way in terms of operation and how things are set up, right? So theoretically, if we included the image of a Docker hub, I can understand that we need to go along, a stricter verification, things like that.
Yeah, I got you. Yes, as you said, like if it's a like very strict, isolated environment and all that, maybe yeah. But again, as I said, I iterate the same point. You're keeping it vulnerable and you're doing an additional workaround stuff. Okay, so I think we just have 20 minutes left. Let me come to this container runtime security segment at the end. Let me just cover the other part so that we can cover the runtime security at the end. So I'll have a very little time, so I'll be covering little quick. And the daemon itself, how do we actually secure the daemon? Is enable the user namespaces itself. What do user namespaces do is like a root inside a container will not be a root outside the container. So by default, if you don't enable the user namespaces, a root inside the container will be root outside the container. And that is the violation of least privilege principle. So you actually need to enable user namespaces. So it's not enabled by default. Okay, so you need to do that. And other thing is the disable communication between containers. So by default, each container can communicate to the other container. Containers means isolation, and you definitely don't want to do that. So there is an option of how you can when I mean communication, it's like a port. So I open a port and then I do a netcat to that particular port from other container. So all sorts of communication between these containers is possible. So you have to do that by changing a flag which disallows communication between containers. So these are all the weak security defaults that I would say. And the one more important thing is like the communication between the client and the daemon itself. By default, it's not secure. As I said, in an enterprise level, people will have client on one machine and daemon on other machine. The entire communication over there is not secure. So you have to do a CA level authentication and a TLS level encryption so that the communication between the client and the daemon itself is secure. So that if I send a Docker pull XYZ, someone in the network will not be able to tamper and change it to Docker pull ABC. So if you do these kind of security things, you'll not be vulnerable to that stuff, or else you are vulnerable to all these kind of attacks. So ulimits is one very good nice control that you can find. Ulimits is something like where you'll see the number of files that a particular container can open, the number of processes that a particular container can spin, the number of process IDs that a particular container can have. All these kind of controls you can actually set up while at the daemon level itself. So by default, there are no ulimits. These are the additional security controls that you can employ in your container ecosystem so that you can make it more secure. Yeah, and authorization plugin. So by default, everyone who is having access to Docker daemon, you know daemon is the more core security part. If anyone is having access to daemon, that means daemon itself is like you're having the entire access to daemon. So thanks to Twistlock who made this authorization plugins open source. Using these authorization plugins, what you can do is like, I have an XYZ user, ABC user, PQZ user or something. So I can say XYZ user will be able to do only these particular operations on daemon. ABC will be able to do only these things. So it provides a fine-grained access control to daemon authorization plugins. That will definitely be useful at enterprise level. Again, this is not enabled by default. You need to do that. And as you know, Docker daemon, if you're having access to, you're actually having equal root privileges. So you should definitely add only trusted users to Docker daemon. So this comes to the more about the Docker daemon security itself. And coming to the host, one very important thing is you should definitely concentrate more on hardening your host where you're putting your containers, because someday, so as you know, Docker security and container security is quite evolving so much. People are working so much on that. Exploits are keep coming up and all that. So if somehow containers, one container is able to break out and then jump onto host, you still want to prevent a lot of exploits like say buffer overflow or ROP or all these kind of memory exploitation attacks and all that. So they're like kernel hardening techniques like GRX, PAGs and all that, GRSec and PAGs and all that stuff, which if you apply on the host machines where you are deploying your containers, will provide an additional security to you, so that if someday, if even someone is able to break out of the container, he or she will not be able to do any malicious things on the host. So that's one thing. And also, I think the first point is about managing up-to-date profile. I didn't actually see that. So up-to-date kernel is definitely needed because it will not have any vulnerabilities. And few security controls, that is something like PID C group, which you'll be seeing in the container runtime, will be enabled or enabled only in the latest versions of kernel. So PID C group, which will prevent fork bombs in containers, is enabled or is available only for kernel versions greater than 4.3. So you should always ensure that, and you have to do general things up to date and hardening guidelines and all that stuff. So we have 15 more minutes left. And coming to the pipeline, the entire view, if you actually see, let me just come here. We dealt about the host security and how we can compromise the host or how you can actually secure it. If you don't do these kind of GRSec or PAGs kind of controls, you are actually allowing, and one day when a container was able to break out to do malicious activities on your host machine. So this is about the host security, and we talked about this saying that it's not encrypted or authenticated. Yeah, it's not encrypted or authenticated, and you have to be very careful about doing authentication and TLS based thing here. And then we talked about the diamond security. Containers is one thing we'll deal about. Images we talked about, and even this is not secure by default. We have to ensure this. Registry security is what we'll not be dealing for today. So this is the entire pipeline view. And before I just jump onto the container runtime part, I'll just quickly take out through the few things, few tips for the enterprises. So these are very crucial tips that every enterprise who are deploying Docker container system has to take care of. So I'll just maybe quickly go through. The secure and ready to consume images are the ones that I said, all about how we take care, like the writing Docker files and enabling Docker content rest and all that stuff. And you have to customize your SecCom op armor profiles as per your organizational requirements. Do not just use the default ones. Change them and use it as per your organizational requirements. And do not share secrets in environment variables. One thing being that if you do it in Docker files, it's visible. And other thing is, like, if you link containers using the legacy linking method, the environment variables in container in one container are visible to the other container. So never use environment variables, and use tools as such for doing a lot of security stuff. And Intel is actually I think they released already something called the traditional TPM TCP thing for normal machines. They have enhanced that to the Docker daemon itself. So if anyone is doing any changes to Docker daemon, the container itself will not boot. That's kind of very interesting work. So optimization techniques and specific rules that you have to create in SIEM, group containers on VM, and all others are like generic things. And so these are the prediction about the container future actually. So hardware level isolation, this is just my opinion, there is no references or something. So hardware level isolation is one thing. So what they're doing is, like, Intel is doing a clear containers concept. They're not actually the namespaces C group containers, but they are lightweight VMs. So they are able to get close performance as Docker, but with additional security of VM. So they're using combination of KMU and KVM and all that stuff. And the other future things, or just my predictions, we should not have no more shared kernel in clear containers, and we should have trusted places for getting images, maybe like Docker store and advanced security tools and inbuilt proper hardening of host. When you install the Docker itself, the host should be hardened with grsec or PAX kind of stuff. And Docker images encryption, the same way how we are doing it for VM. And the same thing, portability between and other just like stuff. So these are just my rest plans for what I'm going to do for the next few days. I'm much going to work on hardware level isolation and all that stuff. So I think I have 10 more minutes. So what I'm gonna do now is just like 5 minutes, I'm gonna cover how much ever I can do the container runtime segment, and the last 5 minutes we'll leave for any questions that we have. Okay, sorry for the way I'm going front and back, but it's all about, I want to ensure that you guys get the most out of everything so that you can concentrate. You have the resources so that you can go out and explore more on that. So within 5 minutes, I'll just quickly wind up this, and then the other 5 minutes for questions. And don't worry about the 5 minutes for the question. I'll be around here for 30 or one more hour, 30 minutes or 1 more hour. You can just come on and talk to me if you have any questions. So the same thing as I said, when you have an image locally, if you do a Docker pull, Docker run, or anything, you get the local copy first rather than getting the updated copy over there. So that's one thing you should be very careful about while you're pulling the image, running an image, or anything. And PIDC group is one thing that I was talking about. By default in a container, so say something like I have a hacking competition and I'm giving one container to each one, and I do not employ any PIDC group limit on that. A guy over there with a simple script for fork bomb, he can just click that and he can crash the entire machine. So you have to do a PIDC group limit, say something like only this number of processes forking is allowed in a container. That you have to do that, or else a container will entirely. So default Docker Zero Bridge is vulnerable to ARP spoofing because you have all of the containers on the same network. So you should be using user-defined networks. And memory limits per container, or like by default, each container has unlimited memory of the entire host. So the same way as I said, if you don't set any memory limits, a guy who is having a container access will be able to DOS the entire machine. So you have to set the memory limits per container manually, and do not use the privileged containers because it has additional a lot of functionalities that it can do. And incoming traffic, it's not that important. And then, so do not share these namespaces of host with the containers, because you containers will have access to see what they are doing and everything. So it's kind of an information disclosure stuff. And then do not disable capabilities. Well, not much stuff. So as I have 4 more minutes, so I'll just talk about capabilities. So system is a capability which is disabled by default, but if you're trying to enable it, you have to be aware that system capability is not namespaced. So if you change a time in the container, and the time will be changed on the host machine also, it will be very crucial security problem when the host machine is used for update mechanisms or any clock synchronizing mechanisms and all that stuff. And no additional privileges is something, and seccom profiles is very crucial. Seccom profiles enables you to sandbox a particular container in its own environment. So say something like I have a container and say that seccom profile is nothing but it has system calls which are actually blocked. So there is a presentation at CanSecWest 2016, I think, where they found a vulnerable system call, and basing on which they are able to exploit that and get out of the container. So if you are not blocking system calls properly, if there is a vulnerable system call, people can jump, break out of the container and then get out. So seccom profiles are very crucial. You have to not just use the default ones. Default ones have like 44 blocked or something, I don't exactly remember. 133 allowed and other things are blocked. So you have to customize this. There have been active research at CMU, few people are doing at Silicon Valley campus. What they're doing is like they're analyzing individual system calls and trying to figure out what kind of vulnerabilities can each of the system call have, so that they can create a foolproof seccom profile list. So that's one area that you might have to concentrate. And CPU shares is also other thing. By default, no CPU shares are set for any containers. So CPU shares work on a relative weighing basis. And AppArmor or SC Linux or additional defense in depth strategies where they allow you to sandbox the entire container and access control mechanisms. And mounts are not that important. And then, yeah, you have to be very careful about the non-namespaced components. There are few non-namespaced components like kernel keyring and then /proc, and there are also like system capability that I was saying about. If you're using those, you have to be very careful, like one container is having access to those. I mean, if a container is using them, say something like a kernel keyring, if a container X is using kernel keyring operations, other container will be able to see them because they are not namespaced. So you have to be very careful about these non-namespaced things. So that's it. I think I did wind up really quick, but I gave you the proper resources where you can go ahead and see. So I think we pretty much covered about everything, maybe what we need about the entire the pipeline itself, what security is that. I'm planning to write a white paper, or else maybe I have few publishers who approached me on writing a book. So I'm thinking about putting all my research findings into that white paper or else a book pretty soon, and I'll update you guys if I get a chance to do that. I don't get time to do all this stuff at CMU at least. So this is much about the entire presentation. Now we have 5 more minutes left. So you can ask any questions that you have in this 5 minutes. Yes, yes, please.
Yeah, are all of the non-namespace components protected by the default sec?
Yeah, I would say one thing, kernel keyring is one thing non-namespace that I said. Default seccom profile blocks all of them. But as I said, people start customizing their own seccom profiles, and they have to be very aware that, okay, if they allow this, these are the implications. So yeah, most of them are blocked. System capability is also blocked by default. Yeah. Yes, please.
CIS 1.2, is there a sort of way to kind of process early in the month? So if I pull a image that's claimed to be, well, I want to compile
I didn't actually get your point. So you mean if a particular image is saying like a compliant to CIS Docker 1.12 benchmark, can I trust it or no?
Right.
So there is,
A lot of the
yeah, the,
ideas, right?
correct.
Based on that. If somehow somebody make an image that is in compliance, basically use all your guidelines, right?
Got it.
And then so, first, is there a trustworthy way to certify an image to be, compliant? And then two, if there is, then can we just trust it?
CIS is just an reference thing so that people can refer it and customize it as per their own internal requirements. So in fact, I have done the same thing at Adobe. So even though I wrote the CIS benchmark part, co-authored with it, I still wrote an internal requirement thing. So each organizations have their own internal requirements. So based on that, we have to tune that. And no CIS do not have any certification thing or something. But yes, all the guidelines that we think like these are the ones that images should follow and all that stuff, we definitely keep everything in the CIS benchmark. There are a few things we couldn't keep in CIS benchmark, say something like use Gosu instead of sudo, because it's more or like Linux best practice, not a Docker best practice. So you have other things which you also have to take care rather than that. But to answer your question shortly, there is no standard certification process. Yes, please.
Can you share the slide deck?
Yeah, of course, sure. I'll send it to them. Yes.
Have you looked at any of the mechanisms being used in Microsoft's containerization in Server 2016?
No. So actually, we have seen my future plans. You can see exploring other container technologies. So few things that are on top of my head currently that I want to explore more are Mesos containers, and I heard like Mesos containers are kind of more secure than Docker, but I just heard it, I didn't work on it. And Mesos or Rocket are the two things that I want to explore first, and then after that maybe I'll shift on to the Windows container segment. Anything else? All right, if you don't have anything else, and if you want to talk to me personally, I'll be around here for some time. You can just come out and talk to me. I also have my, yeah, just a minute.